Imagine a world without smartphones, computers, or advanced medical equipment. A world where technology as we know it has not evolved beyond the bulky, inefficient vacuum tubes of the early 20th century. This was the reality until a groundbreaking innovation in 1947 changed everything. The invention of the transistor at Bell Labs heralded the birth of the semiconductor industry, setting the stage for the digital age and transforming every aspect of human life. The semiconductor industry, often synonymous with Silicon Valley, traces its meteoric rise to a blend of visionary engineers, Cold War exigencies, and serendipitous entrepreneurship. This essay delves into the fascinating journey of this pivotal industry, from its origins in the aftermath of World War II to its indispensable role in modern technology and global economics. The story of the semiconductor industry begins in the shadow of World War II, as nations sought technological supremacy in the Cold War era. It was during this time that three Bell Labs scientists, John Bardeen, Walter Brattain, and William Shockley, invented the transistor. This small device, capable of amplifying and controlling electrical signals, was set to revolutionize the world of electronics. The 1950s saw the transistor replacing the old vacuum tubes, marking the first major leap towards modern computing. The US military and NASA, driven by the demands of the Cold War and space race, became the primary consumers of these early semiconductor technologies. Their needs for compact, reliable, and efficient components accelerated advancements in this nascent field. Silicon Valley became the birthplace of the semiconductor industry's giants. William Shockley's establishment of the Shockley Semiconductor Laboratory in 1956 laid the groundwork. However, it was the audacious move by the traitorous Eight to leave Shockley and start Fairchild Semiconductor that really ignited the industry's explosive growth. This event not only spawned several key enterprises but also established a culture of high-tech entrepreneurship that is synonymous with the region today. The development of the semiconductor industry was marked by several key innovations that fundamentally changed the landscape of technology. The transistor, initially invented for signal amplification, laid the groundwork for more complex semiconductor devices. The real game-changer came with the invention of the integrated circuit by Jack Kilby and Robert Noyce, independently in 1958 and 1959 respectively. This innovation allowed for multiple transistors to be placed on a single chip, vastly increasing the capability and reducing the cost of electronic devices. During the Cold War, the US government played a crucial role in the semiconductor industry's early development. The military's need for miniaturized, reliable, and efficient technology for use in weapons and satellites provided a significant market for the nascent industry. This demand catalyzed rapid advancements in technology and production capacity, setting the stage for the rise of tech giants like Intel in 1968, which would go on to produce the first commercial microprocessor. In recent years, the semiconductor industry has experienced significant growth, shaped by a complex web of geopolitical factors. The COVID-19 pandemic highlighted severe vulnerabilities in the global semiconductor supply chain, spurring nations to reevaluate their dependency on key semiconductor-producing regions like Taiwan and South Korea. The escalating tech rivalry between the US and China has further amplified the strategic importance of semiconductors. This rivalry is not just about economic gains but also about technological sovereignty and security. Both nations have ramped up their domestic capabilities through massive investments and stringent policies to curb the exchange of critical technologies. Moreover, the push for technological self-reliance is becoming a global phenomenon. Countries are increasingly recognizing the strategic importance of having control over their semiconductor supplies, considering these components are crucial for everything from consumer electronics to national defense systems. As artificial intelligence technologies burgeon, the demand for advanced semiconductors that can support increasingly complex AI applications is soaring. Semiconductors are at the heart of AI, providing the necessary computing power to process and analyze large datasets quickly and efficiently. The development of specialized AI chips, such as GPUs and newer AI accelerators, has been critical in advancing AI research and deployment. These chips are designed to handle the vast computations required by AI algorithms more efficiently than general-purpose processors. Energy efficiency has also become a critical area of focus. As AI technologies permeate various sectors, the energy demand of these systems is skyrocketing. Semiconductor manufacturers are thus prioritizing the development of energy-efficient AI chips, which are essential for sustainable growth in AI deployment across industries. Recognizing the critical importance of semiconductors, governments worldwide have introduced substantial incentives to bolster their domestic industries. The U.S. CHIPS Act is perhaps the most significant of these initiatives, providing more than $50 billion in funding to enhance American semiconductor manufacturing capabilities. Similarly, other nations from the European Union to South Korea and Japan have committed billions to secure and enhance their semiconductor production capacities. These investments are not merely financial, they represent strategic moves to assure national security, economic stability, and technological independence in the coming decades. The future of the semiconductor industry is inextricably linked to global technological, economic, and geopolitical trends. As we advance, the demand for semiconductors is projected to escalate, driven by the growth in sectors such as AI, IoT, and autonomous vehicles. Moreover, emerging technologies like quantum computing and neuromorphic computing promise to further expand the boundaries of what semiconductors can achieve. However, the industry must navigate complexities such as supply chain vulnerabilities and geopolitical tensions. As this crucial industry evolves, it will continue to shape, and be shaped by, the global technological landscape, reinforcing its role as a cornerstone of modern innovation.